Wire nuts are excluded from box fill calculations primarily because their volume is considered negligible in comparison to the volume occupied by the conductors and the electrical box itself. The National Electrical Code, often referred to as the NEC, provides specific guidelines and regulations concerning the maximum number of conductors permitted within an electrical box. These regulations are designed to ensure electrical safety and prevent overheating, which can lead to fires or other electrical hazards. The box fill calculation, as outlined by the NEC, is a crucial step in determining the appropriate size of an electrical box for a given wiring configuration. This calculation considers several factors, most importantly the volume of the conductors within the box. The NEC specifies the cubic inch capacity required for each conductor size and type, ensuring that there is adequate space for proper heat dissipation and safe wiring practices. However, the NEC does not mandate the inclusion of wire nuts in these box fill calculations. This is due to several reasons, with the primary reason being their relatively small size. Wire nuts are designed to securely connect two or more electrical conductors, providing an insulated and mechanically sound joint. While they do occupy some volume within the box, their volume is significantly less than that of the conductors themselves. Including the volume of each wire nut in the calculation would add a layer of complexity without significantly improving the accuracy or safety of the calculation. Secondly, wire nuts are not considered a significant source of heat generation within the electrical box. The conductors themselves, when carrying electrical current, generate heat due to the resistance of the wire. This heat must be dissipated to prevent the conductors from overheating and potentially damaging the insulation or causing a fire hazard. The electrical box serves as a heat sink, helping to dissipate the heat generated by the conductors. Wire nuts, on the other hand, do not carry electrical current directly and therefore do not contribute significantly to the overall heat load within the box. Because their contribution to both volume and heat is minimal, the NEC does not require wire nuts to be included in box fill calculations. The focus remains on the conductors, which are the primary source of both volume and heat within the electrical box. It's important to note that while wire nuts are not included in the formal box fill calculation, it is still essential to ensure that the electrical box is not overcrowded. Overcrowding can make it difficult to properly install and maintain the wiring, and it can also impede heat dissipation. Therefore, it is always a good practice to choose an electrical box that is slightly larger than the minimum size required by the NEC, providing ample space for the conductors, wire nuts, and any other components within the box. The specific requirements for box fill calculations are detailed in the NEC, particularly in Article 314.16. This article provides tables and formulas for calculating the minimum size of electrical boxes based on the number and size of conductors, device yokes, and other components. Understanding these requirements is essential for electrical installers and anyone working with electrical wiring to ensure compliance with the NEC and maintain electrical safety. In addition to the volume of the conductors, the NEC also considers other factors in the box fill calculation. These factors include the number of device yokes, such as switches and receptacles, the number of equipment grounding conductors, and the presence of any internal cable clamps or fittings. Each of these factors adds to the overall volume required within the box, and the calculation must account for all of them. It's also important to consider the type of conductors being used. The NEC specifies different volume allowances for different types of conductors, such as solid conductors and stranded conductors. Stranded conductors, which are more flexible and easier to work with, typically require a slightly larger volume allowance than solid conductors. This is because the individual strands of a stranded conductor take up more space than a solid conductor of the same size. When performing a box fill calculation, it is crucial to use the correct values for each factor, as specified in the NEC. Using incorrect values can lead to an underestimation of the required box size, which can result in overcrowding and potential safety hazards. It is also important to follow the NEC guidelines for derriting conductors when multiple current-carrying conductors are bundled together in a raceway or cable. Derriting is the process of reducing the allowable ampacity of conductors to account for the increased heat generated when multiple conductors are carrying current in close proximity. The NEC provides tables and formulas for determining the appropriate derating factors based on the number of conductors and the ambient temperature. In summary, while wire nuts are not explicitly included in the box fill calculations outlined in the NEC, their presence should still be considered when selecting an appropriate size electrical box. The primary focus of the box fill calculation is on the volume of the conductors and other components that contribute significantly to both volume and heat within the box. By following the NEC guidelines and ensuring that the electrical box is not overcrowded, electrical installers can maintain electrical safety and prevent potential hazards. The NEC is updated regularly, so it is important to stay informed of the latest changes and requirements. Electrical inspectors are responsible for enforcing the NEC and ensuring that electrical installations comply with the code. They can provide guidance and clarification on any questions or concerns regarding box fill calculations or other electrical requirements. Proper box fill calculation, as described in the NEC section 314.16, involves several steps to ensure that an electrical box is not overfilled, which could lead to overheating and potential hazards. These steps primarily focus on accounting for the volume of conductors, devices, and fittings within the box, but as previously stated, excludes the volume of wire connectors like wire nuts due to their negligible impact. Firstly, you need to determine the volume allowance for each conductor present in the box. The NEC specifies different volume allowances based on the conductor size. For example, according to NEC Table 314.16b and number 14, American wire gauge or AUG conductor requires a volume of 2.0 cubic inches, a number 12 AWG conductor requires 2.25 cubic inches, a number 10 AWG conductor requires 2.50 cubic inches, a number 8 AWG conductor requires 3.0 cubic inches, and a number 6 AWG conductor requires 5.0 cubic inches. These values are essential for accurately calculating the total conductor volume. Secondly, count all the conductors in the box. This includes all current carrying conductors, neutral conductors, and equipment grounding conductors. Each conductor must be accounted for to accurately determine the total volume they occupy. However, there are exceptions for certain conductors. For example, according to NEC 314.16, bone equipment grounding conductors are only counted once, regardless of their number, if they enter the box. Similarly, fixture wires, as described in NEC 314.16, bone, are not counted if they are used only for connecting a luminaire or other equipment within the box. Thirdly, account for any device yokes or straps mounted in the box. Device yokes, such as those for switches and receptacles, also take up space and must be included in the box fill calculation. According to NEC 314.16b2, each device yoke counts as 2 conductors, based on the largest conductor size connected to the device. For example, if a switch is wired with number 12 AWG conductors, the device yoke counts as 2 number 12 AWG conductors, each requiring 2.25 cubic inches, totaling 4.50 cubic inches for the device yoke. Fourthly, consider any equipment grounding conductors entering the box. As mentioned earlier, equipment grounding conductors are counted collectively as one conductor, based on the largest equipment grounding conductor entering the box per NEC 314.16b5. This simplifies the calculation while still accounting for the space occupied by these conductors. For instance, if there are multiple equipment grounding conductors, but the largest one is number 12 AWG, then the equipment grounding conductors are counted as one number 12 AWG conductor, requiring 2.25 cubic inches. Fifthly, account for any cable clamps or fittings located inside the box. Internal cable clamps and fittings also reduce the available space within the box and must be included in the calculation. According to NEC 314.16b3, each cable clamp counts as one conductor, based on the largest conductor size entering the box through the clamp. For example, if a cable with number 12 AWG conductors enters the box through a clamp, the clamp counts as one number 12 AWG conductor, requiring 2.25 cubic inches. Sixthly, determine the minimum box volume required. Once you have accounted for all the conductors, device yokes, equipment grounding conductors, and cable clamps, you can calculate the minimum box volume required. Sum up the volume allowances for each component to determine the total volume needed. This total volume must not exceed the cubic inch capacity of the electrical box. Seventhly, select an appropriate size electrical box. Based on the calculated minimum volume required, select an electrical box that meets or exceeds that volume. Electrical boxes are marked with their cubic inch capacity, making it easy to choose the correct size. It is always better to choose a slightly larger box to provide extra space and ensure that the box is not overcrowded. Remember, overcrowding can lead to overheating and potential safety hazards. Eighthly, consider any additional factors that may affect the box fill calculation. In some cases, there may be additional factors that need to be considered, such as the presence of splices or the use of conduit bodies. Splices take up additional space and must be accounted for in the calculation. Conduit bodies, such as LB fittings or pull boxes, also have their own fill requirements that must be followed. Ninthly, always consult the NEC for specific requirements and guidelines. The NEC is the authoritative source for electrical safety standards, and it is essential to consult the code for specific requirements and guidelines related to box fill calculations. The NEC is updated regularly, so it is important to stay informed of the latest changes and requirements. The electrical inspectors are responsible for enforcing the NEC and can provide guidance and clarification on any questions or concerns. By following these steps and adhering to the NEC guidelines, you can ensure that electrical boxes are properly sized and that electrical installations are safe and compliant. Proper box fill calculation is a critical aspect of electrical work, and it is essential to take the time to do it correctly. The National Electrical Code, or NEC, Section 314.16 provides specific guidelines for calculating box fill to ensure electrical safety. In addition to the basic calculations, there are several key considerations that can affect the final result. Firstly, conductor size is a primary factor. The NEC specifies different volume allowances for different conductor sizes. Larger conductors require more space within the box. For example, a number 14 AWG conductor requires less space than a number 12 AWG conductor, and a number 10 AWG conductor requires even more space. Always refer to NEC Table 314.16b to determine the correct volume allowance for each conductor size. Secondly, conductor count is another critical consideration. The total number of conductors in the box directly impacts the required box volume. Be sure to count all current carrying conductors, neutral conductors, and equipment grounding conductors. Remember that certain conductors, such as those used only for connecting a luminaire, may not need to be counted, as specified in NEC 314.16 burn. Thirdly, device yokes must be accounted for. Device yokes, such as those for switches and receptacles, take up space and must be included in the box fill calculation. Each device yoke counts as 2 conductors, based on the largest conductor size connected to the device, as per NEC 314.16b2. This can significantly increase the required box volume, especially in boxes with multiple devices. Fourthly, equipment grounding conductors have specific rules. Equipment grounding conductors are counted collectively as one conductor, based on the largest equipment grounding conductor entering the box according to NEC 314.16b5. This simplifies the calculation while still accounting for the space occupied by these conductors. Fifthly, cable clamps and fittings affect box fill. Internal cable clamps and fittings also reduce the available space within the box and must be included in the calculation. Each cable clamp counts as one conductor based on the largest conductor size entering the box through the clamp, as stated in NEC 314.16b3. Sixthly, box volume is a limiting factor. The cubic inch capacity of the electrical box is the maximum volume available for conductors, devices, and fittings. Ensure that the total volume required does not exceed the box's marked capacity. If the calculated volume exceeds the box capacity, a larger box must be used. Seventhly, conductor fill methods can be employed. There are two primary methods for calculating conductor fill: the conductor fill method and the box volume method. The conductor fill method involves calculating the total volume occupied by all conductors, devices, and fittings as described above. The box volume method involves determining the maximum number of conductors allowed in a box based on its volume and the conductor size. Both methods are valid, but the conductor fill method is often more precise. Eighthly, enclosed spaces require consideration. Enclosed spaces within the box, such as those created by dividers or barriers, must also be considered in the box fill calculation. These spaces may reduce the available volume and must be accounted for accordingly. Ninthly, voltage and temperature ratings are crucial. Ensure that all conductors, devices, and fittings are rated for the voltage and temperature of the electrical system. Using components with incorrect ratings can lead to overheating and potential safety hazards. Tenthly, always consult the latest edition of the NEC. The NEC is updated regularly, and it is essential to consult the latest edition for the most current requirements and guidelines. Electrical inspectors are responsible for enforcing the NEC and can provide guidance and clarification on any questions or concerns. The volume of conductors permitted in a box, according to NEC 314.16, ensures safety by preventing overheating and facilitating proper wire management. Overfilling a box can lead to several hazards, including insulation damage, short circuits, and fire risks. Firstly, overheating can occur if the conductors are packed too tightly together. The heat generated by the conductors cannot dissipate properly, leading to a rise in temperature. This can degrade the insulation of the wires, making them brittle and prone to cracking. Secondly, insulation damage is a direct consequence of overheating and physical stress. When conductors are crammed into a box, they can be subjected to excessive bending and pressure. This can damage the insulation, exposing the bare conductors and increasing the risk of short circuits and ground faults. Thirdly, short circuits and ground faults are serious electrical hazards that can result from damaged insulation. If a bare conductor comes into contact with another conductor or a grounded surface, it can create a short circuit or ground fault. These events can cause a sudden surge of current, which can trip a circuit breaker or fuse, but also pose a fire hazard if the overcurrent protection device fails to operate properly. Fourthly, fire risks are significantly elevated when electrical boxes are overfilled. Overheating, damaged insulation, and short circuits can all contribute to the ignition of combustible materials in or around the box. Electrical fires can spread rapidly and cause extensive damage to property and pose a threat to life safety. Fifthly, wire management becomes difficult in overfilled boxes. It becomes challenging to properly arrange and connect the wires, increasing the risk of loose connections and accidental disconnections. Loose connections can cause arcing and overheating, further exacerbating the fire risk. Sixthly, inspection and maintenance are hindered by overfilled boxes. It becomes difficult for electrical inspectors to properly examine the wiring and connections, making it harder to identify potential problems. Similarly, maintenance personnel may struggle to access and repair the wiring, leading to delays and increased costs. Seventhly, compliance with the NEC is essential for ensuring electrical safety. The NEC provides specific guidelines for box fill calculations to prevent overfilling and minimize the risk of electrical hazards. Failure to comply with the NEC can result in fines, penalties, and liability for damages in the event of an electrical incident. Eighthly, proper box fill calculations help ensure the longevity and reliability of the electrical system. By preventing overheating and insulation damage, proper box fill can extend the lifespan of the wiring and components, reducing the need for costly repairs and replacements. Ninthly, safety for electrical workers is enhanced by adhering to box fill requirements. Working in an overfilled box can be dangerous, as the risk of accidental contact with live conductors is increased. Proper box fill provides a safer working environment for electrical workers. Tenthly, consider future expansion when determining box fill. When installing wiring, it is always a good idea to consider the possibility of future expansion. Leaving some extra space in the box can make it easier to add new circuits or devices in the future without having to replace the entire box. In summary, the National Electrical Codes, or NECs, regulations on conductor fill-in electrical boxes are crucial for preventing electrical hazards and ensuring the safety and reliability of electrical systems. By following these guidelines and performing proper box fill calculations, electrical installers can minimize the risk of overheating, insulation damage, short circuits, and fires, creating a safer environment for everyone.